So we have seen the last class measure of variability. In that we saw range, variance, and dispersion. And you're looking at a dispersion. We mentioned yesterday that how measure numbers. All right. More the variation, more the deviation. And in terms of dispersion, it says it is a measure of dispersion of set of data from its mean. That means it is measuring from the middle point of the numbers. From there, how it is going to be dispersing. Dispersing means spreading across. Okay, it is like a pyramid at the middle. If I measure on the left side how it is tilting and on the right side how it is tilting, so then I am actually looking for a dispersion of the decrement of the height of the pyramid's each part. Alright, so that dispersion of the numbers or dispersion of the values from the middle part, not from the beginning of the numbers. Okay. Earlier variance, we said that it simply describes how much random variable differs from expected value, and also it also computed as a square of deviation. We saw that how numbers are when numbers are varying, how those numbers are giving us the standard deviation as increased value. Okay, more the standard deviation value, more the variance, more the changes in the numbers. All right, variation in the numbers. And dispersion does the same, but it is not considering all the values from the beginning. It's considering the values from the mid part of the numbers. Okay, let's see some examples. This way you can look at the dispersion. Dispersion, measure of dispersion. So from the middle of the numbers, so consider this x-axis is having numbers, and from the middle part of it, how the numbers are going to vary. Okay, so is the middle number is larger than the other numbers, and how it is spread across. That is going to measure it. And importantly, we go to GFG and have some examples. Absolute and relative, two keywords you can see here. I hope all of you understand the meaning of absolute and relative. Absolute is the actual value, and the relative is the value which is measured with in reference to the other value. All right. Absolute measure of difference, dispersion. These measures of dispersion are measured and expressed in the units of data units. For example, meters, dollars, kg. All of them are units to measure the dispersion. Range, mean deviation, and the standard deviation. We saw this and this. What about this? Mean deviation. Arithmetic mean of a difference between your values and their mean. What does it mean by this word mean? We discuss average of all the values. So we are saying this is the arithmetic mean of difference between the values and their mean. So that's what we are saying. How the average value is deviating from all the other values. Standard deviation. This is the square root of the arithmetic average of the square of deviation. Yesterday we saw deviation is measured from its mean. This is about the range. The smallest value S in the data is 0. The largest value L in the data is 100. So the maximum value in the range is 100. Minimum value in the numbers is 0. So 100 minus 0 will students in Karnataka have taken passing marks starting from 210 till 620 marks. All right. It is similar example. Mean deviation. We have a -5, 10, and 25. The mean of this data is 10. Is that right? Mean of the data is 10. Yes, 10. 30 by 3 is 10. 30 by 3, yes. 30 by 3 is 10. Now the deviation from the mean for different values is -5, -10, 10, -10. The deviation from mean for different values. So for this one, what is this? That is this much. How about this one? It is 0 and there will be 50. What is this? This is a deviation from the mean. Okay, that's what we are taking this as a mean of the data 10 and subtracting each time to the each values that we have here, and we are able to find out the deviation. Now, then adding the deviation shows that there is zero deviation. There is zero deviation from the mean. Is it right? It says there is zero deviation from the mean, which is incorrect. Thus, to counter this problem, only absolute values of the difference are taken. Absolute values. So, mean deviation, not a standard deviation. This is mean deviation. Will take here x1 minus mu plus x2 minus mu. We have taken these bars to make sure that all the values will be positive, absolute values. X10 divided by n. Mean deviation from the mean for ungrouped data. Mean deviation for calculating the mean deviation from for the ungrouped data, that is individual data. You must follow these steps. Calculate the arithmetic mean for all the values in the data set that we did in the beginning. Calculate the difference between each values of the data set and the mean. Only absolute values of the difference will be taken out. All right. For that, you need to have the mean deviation equal to d divided by n. That is, the differences will be considered here, and we are dividing it by here. If you take an example, you'll understand. Calculate the mean deviation for a given ungrouped data. This is the data that we have, and we are going to use this d. Mean equal to mu equal to 2 plus 4 plus, so all the numbers have been added, and we are dividing into 5. What you are trying to find out? You are trying to find out the average or the mean. Then we will have the mean as 6, that's mu, and then MD, that is a mean deviation, equal to summation of d divided by n. Okay. What is summation of d means? It means it is the individual values being subtracted from the mean value. Okay. Individual elements are 2 minus mean is 6. 4 is your individual element minus 6. So like that, all the values will be taken up, and definitely will be dividing it by the number of count of values they added, and you'll be getting 12 by 5, which is 2.4. That will be your mean deviation. All right. Let's get back to dispersion. Okay, I hope all of you understood what is dispersion. We just saw mean deviation. It's related to the dispersion of absolute as well as relative. We saw that measure of dispersion. I hope all of you are very clear with the measure of dispersion, which is a scattered data. How the data is scattered, that we will be able to measure with the help of dispersion. Alright, it's a measure of variability. Variability is nothing but changes in the data or variation in the data. That's what happens when much of the data is randomly arranged. Okay, so how scattered or how random it is, that randomness will be taken care of. Okay, but the randomness is not directly taken; it is taken from the mean, from the middle. So how the bell curve is being formed. So that's what it is going to check on either side of it, how it is going to be spread across. Okay, these measures capture the variation between different values of the data. Intuitively, a dispersion is a measure of extent to which the point of dispersion or a distribution differ from the average of distribution. You understand this? It says distribution differs, the point of distribution from the average of distribution. What does that mean by distribution differs? How the distribution differs? A distribution differs randomly from the average of distribution. Average of distribution is the commonalities in distribution you are trying to find out. Alright? How it is different from the average distribution and how it is different from the generally measure distribution. Okay, let's look at an example. We have different types of dispersion, but you don't have much details on it. We don't have much examples onto this. Statistical distribution. Yes, we have this unique example. Let's take this. Theoretical normal distribution and the data fit in the normal distribution. Theoretically, it will look like this: the data. These are standard deviation. You are trying to study this part of the standard deviation from the mean. Mean is this middle point that we have, and this part of the data we are trying to study. Okay. We are taking the range of this one. So this part of data we are going to study, only this part. Okay. This may be having some values from this point till this point. Alright, that's a range of data. The height is nothing but the range you have it, and that axis you can see on the left side. This is the one more parameter that you will be considering when you are measuring. Alright, we have the standard deviation for this one. That is your we are going to multiply it by 2 again as we find out for one thing. It is 68.3 of distribution, and this is 95%. This whole thing. Okay, till where we are calculating, and that gives us the total distribution. That is 99. This is 68. This is 95, and this is 99 distribution. Same thing, data fit in the normal distribution. These are theoretically, you will say normal distribution looks like this, but this is the data that fit in normal distribution. 67.8, 95 point something. Similar to that, but it is going to have some more data points which are not smoothly transitioned. Okay, here we say that the data is changing smoothly, but actually it is not. That is the dispersion. I hope all of you understood. You just need to understand the theoretical concept of it. Programs will be doing it once we have completely understand these keywords and everything. Alright. I hope you understand a range, variance, and dispersion. Alright. Okay. Inferential statistics. What does it mean, inference? English meaning of it.
to infer from the given data set.
Yes. Heard of it earlier? Getting motivated from. Okay, let's give an example. Okay. Characterized. Okay, we have an example. He has to construe the knowledge as inferential. Relating to, involving, or resembling, or similar to, resembling inference, or deduce, or deducible by inference. You understand these words? Affecting or relating to, involving will be the meaning. You understand these words? Involving or resembling to inference. That's what it is. Synonyms, relative, reducing it. Okay. How about inferential statistics? What does it say? It says it describes the many ways in which statistics derived from observations. Statistics derived from observations on samples in the population from study populations can be used to deduce whether or not those populations are truly different or same. Right? Are they truly different or same? So to deduce that, we have this inferential statistics. Okay, so we need to have a reasons to inference on. So that's why it is saying it's going to describe many ways in which statistics derived from. What we do? Statistics derived from observations. What does that mean? Statistics derived. We are going to deduce or we tell some number based on the derivation of the data that you are giving me. We have taken some data earlier. Based on that data, I'm going to give you the standard deviation. Alright. So we derive our final value from the number that we are giving. Okay. So here we are saying statistics derived from observations. Observations on samples. Yesterday we took the observations as N value, capital N. Alright. So how many values we take? 6 values taken. Sometimes we are taking 8 values. So those are observations. Okay. That's the one. We have an example. Okay, let's go back to our slides. Inferential statistics makes inference and prediction about population based on the sample data taken from the population. Again, we need to understand the meaning of this inference, then only we can understand. I hope you understand the statement that we are making here. We are saying inferential statistics make inference. Inferential statistics makes. You understand the meaning of it. What does that mean, prediction?
Prediction or deciding advance on achievement.
Deciding advance.
About any reason. Say from the sample.
That's planning.
From the sample, I get some insights.
Okay.
So those insights will be applicable to the population, entire population.
Okay.
So if my inputs are there are 100 students.
Okay.
So I randomly pick 10 students and take a test on them.
100 students test. Okay.
So I randomly select 10 students. I take a test on them. So out of 10, they all will pass with 80% marks.
Okay. All
will pass with 80 to 90% marks in that range. So now I infer that my school, all students are passing in the range 80 to 90.
Yes.
Because 10 students are picked.
Yes.
Because they are randomly picked.
Randomly picked.
I have not picked them from one corner. I have randomly picked the students.
Okay.
And what is the result of those 10 students? I'll apply that to entire population.
Right.
So here, sir, and inference is the process of applying my findings from the sample to the entire population.
Yes, that's right.
That's why.
Yes, right. Inference, and it says prediction about population. When it says also and also prediction, that means it is based on some data that it has got in inference. It is also going to predict something. All right. So understand what is prediction, because AI, when you hear the word, you will definitely hear the prediction. Okay. So what is prediction?
Probability.
Probability. Okay.
Forecasting. Forecasting.
Guessing. Okay. Yes. Okay.
Forecasting future events.
Forecasting. Forecasting. Future events. Forecasting. Forecasting. You will understand. Weather forecast. They predict it. IP. IPL match prediction. Awesome. Okay. Point toss will be one of the ways which we predict. What is the difference between prediction and planning?
Planning means we have to do.
Planning is we will knowing the subject.
So we will be knowing the subject. Okay.
We can say that we will be
On
not
prediction and planning.
in prediction we don't know the results, but we predict that this is going to be.
Maybe right. Okay. Planning.
Planning we know that if we do it will come. This only we will get it. We know.
That's planning.
Most probably, prediction will be wrong, sir. Almost, but planning will be.
Okay.
And it's now.
Maybe you are creating a relation between both the words.
So planning,
Individually you can answer.
in planning, sir, we want that thing to happen. We plan for that thing, sir.
Right.
So in prediction is not in our hands. Whereas planning is in our hands.
Okay. So both are different. So both planning and prediction, outputs will be known or unknown. No.
In planning, sir, our outcomes are known, whereas predictions, outcomes are not known.
Outcomes are unknown. Okay. So how about if I look at in an angle of planning is future actions. Planning is future actions. If I say, how about prediction? I'm defining planning as future actions being documented in present. Okay. If I define like this, so how do you define the prediction? That's how your AI. Once you understand this word, meaning you understand the AI.
So planning, I'm planning to wake up tomorrow morning 5 a.m. and then go to school at 7 a.m.
Okay.
I'm planning.
Planning.
I know
Future actions.
Huh.
Those are future actions.
Those
5 and 7.
Those things will happen for sure. They are under my control.
Okay.
Tomorrow whether rain may come or may not come. I know what may happen, but I can't tell this thing to happen or this thing to happen.
So
They are not
in
under my
that,
control.
in that,
Either
can
this
I also
or this will happen, but one of them will happen for sure.
can I also say that they are also future actions,
They are future actions.
but if you
Depending
use
on
but depending on data.
Planning is a big description.
What is description?
It means performing the action on them.
Planning means
It is a big description.
brief description.
And usually means performing the action.
Prediction means performing the action. Prediction means performing the action.
Sir, I'm planning to toss the coin tomorrow
Okay.
before the match.
Plan. It's not.
planning to not the points.
Okay.
Prediction is, it may be a death or it may be a health. That is prediction. It is a faith. That is the prediction.
Okay. You see, there is a very slight difference that you see in planning and prediction. In prediction, you do not have any control definitive, but you predict it will happen. Okay. So the outcome you are expecting, but it is going to happen or not, it is based on the probability of the outcomes. If you come down to the planning, in planning you list out the events or you just decide in future these kind of events will happen. Alright, again they will happen or not, it's based on execution, but you're just planning that these things will happen. So you have definite that these things will happen. So in prediction, you do not know what will happen. So one is uncertainty, one is certainty. Alright? So one is certain, another one is uncertain. So certainty is the question in both of them. You need to understand this. Same thing we will study in AI as well as in ML. How certain I am. I'll be having a control over things when I'm certain about it. When I'm uncertain, I will leave it to a random situation. Alright? So certainty and uncertainty will be.
If I am planning something to do, but my outcome is not that much planned proper.
Correct. 100% plan, but 90% happening.
Yes.
Correct.
Then how come it will be certainty?
That's what I told. Your certainty will be in terms of planning your actions. As I told you, future is a planned actions. I mean, the pre-decided actions to be taken in future. All right, planning is future actions. Agree? In prediction, you have uncertainty. Here you have certainty of actions. You may take them or not, it's up to you. But you are making it certain that they will happen. Alright? 100% or 80%, 90%, it's up to you. In prediction, you cannot say that. I have planned 100%, it's happening that way. So again, that 90%, 80%, that also we don't have any prediction. I mean, we don't have any planning. So planning can be said to as a certainty in deciding what will happen. And in prediction, we do not have any certainty, so we are saying it as uncertain in predicting the outcomes. So it depends on the probability of the situation or the data that is supplying. Okay, so that way we say inferential statistics, which is going to give you the inference or making a decisions. Inferential statistics makes inference and prediction about population, which is a data or any group of people or persons or an object, or prediction about population based on sample of data taken from population. A part of the data taken from population will be used to apply inferential statistics, and based on that outcome, we will be going to make an inference saying that this is how it happens, and also make a prediction. Alright? You understand both those words. This is your planning. I mean, this is your actual outcome. Presently, I am giving. This is inference. This is what it is happening. Present. Future prediction. Clear? Inference is I have the data. And when this will happen? Present. Okay? Future? I don't know. But I am applying the same outcome or same formula to all the population. Because I have just taken a sample and I am telling you this will happen. But I don't know what is the, when I apply this same formula to the whole data, what will happen? So that will be one of the That will be one of your prediction exercise, a prediction way. You are going to apply to the whole population, then you get a prediction total. Alright? If you have 1 lakh data, you just taking 100 numbers and just checking whether it is working or not. Then apply it for whole 1 lakh. Then you say, for all other data that will come in future, for them, this will happen. Alright? This is how theoretically you can understand that. It generalizes. What does that mean? It generalizes. Do you understand it? It generalizes. It generalizes the large data set and applies probabilities to draw a conclusion. Recently, voting happened. You apply this sentence from this point to this point. You apply this sentence to the recently election happened. So that you apply and let me know how you understand this. I tell you each words here. It generalizes a large data set. Okay, it takes the whole data set and applies probabilities. Apply probabilities. Probability is a mathematical concept where you analyze the outcomes based on the possible options of outcome. Head and tail. When you do, you have head or tail, two possible options. But how do you say when I toss 2 times, tail will come? Okay, there are 2 possibilities. The tail will come. Okay, when you do the combinations, when you do the combinations. All right. So that's probability. Applies probabilities to draw a conclusion. Generalizes a large data set and applies probabilities to draw a conclusion. It is applying the inferences that it has taken onto the larger data sets. We understand that. And we also saying that we'll apply the probability. Okay, probability is a technique where you try to find out different combinations of outcomes, and then you check how probably these kind of outcomes may come. All right. I hope you understand the keyword probability. If not, I'll take an example. We take an example. Yes.
It's like 50 hours.
50 hours, correct.
By watching those 10 hours,
Okay.
batting team scores 10 hours, 20 runs. Okay. Now I tell that Korea,
Prediction.
I'm not declaring that they will score 100 runs. I'm not declaring. I'm just inferring based on this 10 hours. Then this is the statistics available with me. 10 hours scored, 20 runs scored. 12 over 2 runs. So I infer that for 50 overs at the rate of they will score 100 runs. I'm inferring they will score 100 runs.
Listen here,
ನನ್ನ ಅನ್ಸುಮಟ್ಟಿಗೆ 50 100 ರನ್ ಹೊಡಿಬಹುದು. ಈಗ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಮತ್ತೆ ಈಗ ಬ್ಯಾಕ್ 50 ಓವರ್ ಬ್ಯಾಕ್ ಫಸ್ಟ್ ಓವರ್ ಬೌಲಿಂಗ್ ಆಗ್ತಾರೆ. ಇದು ಬ್ಯಾಟಿಂಗ್ ಇಂದ 10 ಓವರಿಗೆ 20 ರನ್ ಹೊಡಿತಾರೆ ಇಂಡಿಯಾ ಟೀಮ್. ಅವಾಗ ಏನು ಆಡೋದಪ್ಪ ಸರಿ ಆಡೋದಿಲ್ಲ 10 ಓವರಿಗೆ 20 ರನ್ ಹೊಡೆದಾಗ ನನ್ನ ಅನ್ಸುಮಟ್ಟಿಗೆ 50 ಓವರಿಗೆ 3 ರನ್ ಹೊಡಿತಾರೆ. ನನ್ನ ಅನ್ಸುಮಟ್ಟಿಗೆ 3 ರನ್ ಹೊಡಿಬಹುದು. You are not declaring that 50 overs they will score 100 ಅಂತ ನೀವು ಡಿಕ್ಲೇರ್ ಮಾಡಲ್ಲ. 50 ಗೆ 100 ರನ್ ಹೊಡಿತಾರೋ ಅಂತ ನೀವು ಬರ್ತದೆ. You are just telling the probability. You are inferring it. statistics available with you is 10 crore and 20 runs scored. 50 crores based on this inference, 50 crores they will score 100 runs. So this 10 crores data you are applying to 50 crores. That is the inference.
So here 10 is sample,
10 crores is the samples.
50 is
50 is the population.
population. Okay.
Uncertain. The 11 to 50 was there in 50 are uncertain. You don't know that. That's why we are inferring.
Okay, got it? We are lucky that we have him so that we can have a generalized example so we can understand.
So these examples we can understand.
Yes. Okay, try to understand a little about the probability and then we'll go back to that. Else you'll not understand the complete sentence. Probability is a branch of mathematics. Probability tells how likely an event can occur. How likely an event can occur. Alright? In single word, it can be possibility. Probability can be a possibility. That is the possibility of happening an event. And always it is between 0 and 1. 0 to 1. It will be any fractional number. Probability will be represented between 0 to 1. It cannot be more than 1. So if it is, if it never happens, the value will be 0. If it is guaranteed that it will happen, the value will be 1. If I say 50% it will happen, 0.5 is the probability. Get it? No, I don't know, but 30% will happen. That means it may happen 30%, or it may not happen 70%. Get it? You have to divide between 0 to 1 itself. Your probability values. All right. Probability of an event equal to number of favorable outcomes. What does that mean? Do you understand this word? Favorable output, favorable outcomes. Possible outcomes. You understand that? Possibility of, possibility of those options, outcomes. Okay. When I toss a coin, it may be head or tail. So those will be my possible options. Alright, outcomes that I will be getting. So number of favorable outcomes divided by total number of possible outcomes. Alright, okay. Coin toss probability. There are only 2 possible outcomes when coin is tossed. Coin is tossed. Those are head and tail. So as per the above formula, the coin toss probability is given as coin toss probability possible outcomes. Total number of possible outcomes equal to 2. Is it right? When a single coin is tossed, the total number of outcomes. This is not minus. This is just hyphen. It's hyphen actually. Total number of possible outcomes is 2. So simplify above formula with this one. Total number of favorable outcomes divided by 2. So we got one number, that is denominator. So you have problem statement. What is the probability of getting head as a toss when a single coin is tossed? 1? Sure. 50%. 50%. 50%. 2 options there. Anyone can. Let A be the event of getting head. A will be designated as head event. When the coin is tossed, the number of favorable outcomes will be head, that is 1. As per the coin toss probability formula, when the single coin is tossed, the probability of getting the head, we just made A as the event which is getting head. Okay, so P is for probability, P capital P probability, and A is the event which is designating head. The probability of getting head equal to number of favorable outcomes divided by 2. Same formula will be applied. Now here we have how many outcomes for the head? The number of favorable outcomes is 1. So here we are asking number of favorable outcomes. Here you can replace this word with a 1. So you can say 1 divided by 2. So probability of getting head is 0.5, that is 50%. But this is how probabilities will help you in predicting. What will come? 50% head will come. That means I am also saying that 50% tail will also come. Alright? Okay. You solve this. What is the probability of getting at least one tail when 2 coins are tossed? Thinking much? Is that simple? Isn't it simple? When the coin, what is the probability of getting at least one tail when 2 coins are tossed? This is the coins are increased. That's it. Now you need to check what will be the outcomes. 2 coins means 2 coins you have to hold it to toss it. At a time, both may be heads, both may be tails. 2 options covered. One tail, one head. Okay. So how many options you have totally? 4 options. Alright. The number of favorable outcomes will be 4. And we say something here. Let be the event of getting at least one tail when 2 coins are tossed. Okay, one of them will be tail. We are considering 3 by 4. Yes. Okay. Number of favorable outcomes will be header, tailor, tailor, header, then tailor, tailor. Will be 3. And both comes as head. No? Why? So all the combinations that you are making will must have at least one tail. Okay, total possibilities, possible outcomes, that is head, tail, tail, head, tail, tail, head, tail. Total possibilities is this much. That is 4. As per the coin toss probability of getting at least one tail, when 2 coins are tossed, will be equal to, this is your event of getting at least one tail. I hope D, and this P is for probability. Number of favorable outcomes, how many? 3. Having at least one tail divided by total number of outcomes. So it will be 4. 3 by 4 will make it 75%. 75% chance of getting at least one tail when 2 coins are tossed. Is that right? Yes. You can experiment. You can toss it. Again, it depends upon how many times you are tossing. Here we not mention that thing. What is the probability of getting at least one tail when the 2 coins are tossed? Only one time. One time case study. When you toss it multiple times, I mean the question will change. When I toss 3 times, the coin, how many times tail will come? This is again like predicting multiple variables. Alright, this is only one time. We are just checking what is the probability that we will get a one tail at least. What is the probability of getting head or tail when 2 coins are tossed? What is the way of getting head or tail? 2 coins are tossed. 2 coins are tossed. The same question. Only the focus is here. Head or tail. Okay. How do you say? C be the event of getting head or tail when the coin is tossed. Number of outcomes will be only 2. Head or tail, number of outcomes. As per the coin toss probability formula, number of outcomes divided by 2, because the total number of outcomes will be 2 itself. The number of favorable outcomes are 2. Here we have 2 by 2. That means 100% Any one of them definitely will be head or tail. The question should you can understand.
What is the probability of getting head or tail? Head or tail when
Two points are tossed. There is no third place to get it. Obviously, any one of them will definitely come. But definitely means what? Definitely means it's one in the probability value. Alright? Okay, that is how prediction will work. Prediction work like this. And obviously, it's not a magic. We are getting a number, we are getting an answer also at the end. And that's not a magic. When these numbers and possibilities will increase in number, then you are not able to analyze how it is happening. But definitely something calculation is happening. Definitely computer knows how to do the calculation. But in terms of larger numbers and larger counts, it is going to do. Then you see that okay, something is happening which looks magical, right? That's not at all magical. It is probability and a lot of other mathematical equations which are working behind the scene in terms of algorithms. That's why it is happening. All right. Okay. I hope we understood the probability. We'll come back to.
Okay. Now let's understand this statement. It generalizes a large data set and applies probabilities to draw a conclusion.
So we have understood how we can give an outcome in probability. Same thing we are trying to apply for the whole data set because we have to have inferences being done whole data set as we are trying to generalize the one outcome from one sample to the whole samples, whole the population. Got it? Let's go ahead.
All right. It is simply used for explaining meaning of descriptive statistics.
We just now saw one of the examples of descriptive statistics. We are mentioning that there is a 75%, 50% chances are there that you will get a 70 or something. That's your population totally. One statement I want to make on the 1 lakh records. One statement I want to make. This is how these things are. That will be my outcome of the whole inferential statistics. That's why we are saying that saying it as inferential statistics. I am getting influenced. I am getting influenced by the data that is available with me. Based on that, I am going to inference to say the one statement which is my outcome. As we are seeing with the toss of coin, and at the end you have seen
that they are making one statement.
So that is good. So we are trying to frame the whole solution in one statement. All right. So they say there are 75% of chances of getting
At least one tail when two coins are tossed.
So they are telling in terms of number also 75% is number that we got to know with the calculation, and you also understand what is the meaning of 75%.
It means that getting at least one tail when two coins are tossed.
All right.
With the help of calculation, we can just get a number,
But you cannot tell what is this 0.75.
when you tell this whole thing,
Then you are inferring based on the data that you are receiving from the question. All right. Okay.
Inference statistics mainly related to and associated with the hypothesis testing. One more keyword
We have called hypothesis testing. Now, all of you have heard of hypothesis. What is the meaning of it, and how can I understand it in simple words? Very heard hypothesis.
Photosynthesis.
Hypothesis, photosynthesis. Looks poetic like a thing, but what is the meaning of that? Hypothesis.
Hypothesis is today 1 lakh babies are born in India. Sir.
Okay.
Okay. I'll make a hypothesis that out of 1 lakh babies, 15% are male, 50% are female.
Okay.
This is my hypothesis.
Okay.
This is my hypothesis. Okay. So to check whether my hypothesis is correct or not, I will go to 1,000 babies. That is 1% of the population. So for one, I check for 1,000 babies, if the data is 500 male and 500 female. Okay. So 50% male, 50% female is there. So I have already made a hypothesis for the entire population that 50% is male, 50% is female. If this hypothesis is working on this sample data, then what hypothesis are made for entire population will be correct, and I can generalize that.
Yes. You understood what you mentioned? Okay. Well, I'll do one more example. 50% understood. That's hypothesis again.
And after the class, you say that okay, you have understood. That's also a hypothesis.
90%.
But then this is not hypothesis.
We need to check it in the next class.
Hypothesis testing has to be done.
Same thing will be, same concept is known strongly by Anil Ayasa. They asked us to revise what we studied in last class. We tried to understand that hypothesis concept.
How much they understand?
How much they have understood. That is proof of hypothesis. Hypothesis is the assumptions that you are making at the beginning before you get to the outcome as an outcome or an answer. Okay. You arrive to an answer. Okay. But again, the question comes is how hypothesis is different from probability. Two words we have. How do I understand? Because I am getting confused because probability is one concept, hypothesis is another concept. Probability is having the evidence of why the outcome will be like this. It is having concrete number of outcomes and concrete number of possible outcomes. Okay. In assumption or hypothesis, we do not have a concrete base on which we can make a hypothesis. We just randomly add something. Okay, that will be hypothesis. So hypothesis, randomly means we know some value, some range, but again that range is so vast, we can say it is again random. Alright, again as AI students, we need to understand randomness doesn't exist. This statement is true for all the information that you get on internet. Probability exists, and randomness doesn't exist. Alright? If I tell you to generate a random number, you cannot generate a random number. You will definitely generate a number which is possible to have a pattern to generate a. Alright? Understand that? How can you generate a random number?
Actually, this was one of my doubts in that question. Write a program to generate a random number. We usually can generate a random number between 1 to 10. But how the system can generate a random number between 1 to 10? It needs something. Based on that, it can generate a number.
Yes, that's right.
So later I found out that they derive a random number based on the timing in the system.
Timing is one thing, but timing any value you take, that we call it as a seed value. Yeah. So whenever you try to generate a random numbers, it needs a seed value. Okay. Seed value is initial value, so that you can start generating those random numbers. Okay. Randomness doesn't exist because random numbers getting generated from a definite range of the numbers. So in that numbers itself, any number will come. Okay, that's why the numbers that you generate are not random; they can be predicted. The only difficulty is they are so random that it is difficult to find out how the pattern is. Okay, but in a larger way, if you look at it, Is the random numbers are random? No, they are not random. They are having a pattern of generation. But for our usage and for making them look random, we can say they are randomly available. So connecting that concept to hypothesis, we assume some value that this will be the right value to take it as a calculation. Will be our assumed value that may give us the right outcome or may not give us the right outcome. But at the end, we will understand that whether if I am getting a right answer, that means my assumption is right. That's why the calculation went right. Okay. So assumption here PPI will have some framework. Based on that, if you go and do the assumptions, you probably not photosynthesis.
Testing whose main target is null hypothesis.
No, sir told me and feel I'm not feeling that. I'm saying
Okay, inferential statistics is mainly related to we say associated with the hypothesis testing, whose main target is to reject null hypothesis.
Null hypothesis is concept where an hypothesis which doesn't lead to a favorable outcome. You are actually expecting some outcome. This hypothesis that you have made is not at all giving you the right outcome. Then you can say this hypothesis must be rejected. So such hypothesis which we will reject it, we will call them as null hypothesis. Right? Understand?
Okay, so what we are trying to say, it is mainly related to hypothesis testing, whose mainly we are trying to avoid the bad assumptions. Hypothesis testing is a type of inferential procedure that takes help of sample data. What it is trying to say? Inferential procedure. Inferential procedure is nothing but you are trying to analyze the data with the help of assumed value. Assess means evaluate. Another word is evaluate. Okay. Evaluate and assesses credibility of hypothesis. Credibility of hypothesis. Hypothesis, you understand? Okay. Assume the value, assume the statement, something. How about credibility of hypothesis? Credential is user password. Yes. Evidence. Credibility of hypothesis. Evidence of hypothesis. Not exactly. Near.
Credibility, dependability, reliability.
Yes, reliability is the right word. You can define it. Okay. Credibility is how strongly I can believe on the hypothesis. Will be the credibility. Okay. If government give you a role, how credible you are to take up that role and complete your job. That means they believing on your capabilities and when they are giving you the role. So you are a credible person to hold that role. That you can answer. Alright. So here we are talking about hypothesis. That means we are taking a random number, but we are how credible it is. We are going to assess that with the help of sample data that we take. Alright. With the help of sample data to evaluate and assess credibility of hypothesis about population, the whole population. Because of the sample data, we have some inferences ready. Inferential statistics are generally used to determine how strong a relationship is within the samples. Within sample means there are multiple samples available, but only one sample is being evaluated, and other samples are has to be evaluated. And now the thing is which sample I should take it, and how should I create the relationship between them? Because the data that we are considering will be the Excel sheets column. If you imagine, I have taken only few numbers from the beginning, and other numbers are not considered. But if you look at other numbers, they are also related to the beginning numbers. Okay. So how
are they related? The other data that is remaining, how they are related, how they are interrelated, that we need to check it with them first. Inferential statistics are generally used to determine how strong relationship within sample, but it's very difficult to obtain population list and draw a random sample. Obviously, we have to look for this, look for the possible option of which sample I should pick it, and I should consider them for the next calculation of adding the same formula as we added for the previous sample. Get it? For example, I have 100 numbers. If I consider my 10 numbers as a one sample, so I have 10 samples available. Okay, 100 is my population, and first 10 numbers are my sample data. So I have calculated everything and it's working fine for my 10 numbers. Now I have to apply for all the 90 remaining numbers, which is a set of 10 numbers. Alright, so that I'm going to predict it based on the relationship that I'm establishing between all the group of numbers, all the 10, all the 9 combination of 10 numbers each. Alright, then we will be going to consider samples. And we try to predict as we did for the first 10 numbers for all the other 9 combinations. Got it? Okay. That's what we do in terms of testing and training of the machine learning algorithm. Whenever you do the same thing, I mean you do regularly in your life the same thing. You take up some information and you tell it to somebody. And you just see for some days whether that information he's consuming, he's spreading it outside. Okay, if he's not spreading, he will become closer to you and you share more information that you have. But you will not share all the information with them. A little more secret information you will share. All right, you go on, check the person whether he is credible or not. You just hypothesize that this person is good. As time passes, you give more information. You give more information. So the person becomes closer to you, and you also assume that, okay, I have assumed that this person is good. Now I can rely on the 50%. What you're doing, you're proving your assumptions right. Okay. And for somebody you have believed that the people are good, but you heard that the person is done somebody or he has made something bad with somebody, you reject your assumption that okay, I thought he is good, but he is not good. So what you are doing, you are rejecting the hypothesis. That means you are targeting the null hypothesis. Alright. So as you give more and more information, that means you are trying to create a more connection between your friend and yourself with the help of data or the credibility of data security between you and your friend. Alright? Why? Because you are thinking that my hypothesis is getting proved day by day. My hypothesis is the person is good. How much good you are evaluating day by day. Alright? That is how an algorithm will try to use data every time its hypothesis is getting proved or unproved. Both the way possible. If it is proved, then the same proof will also apply to other samples. If it says my hypothesis is being negative, I will not apply. I reject the hypothesis. Alright? That is how inferential statistics will say the data that you are taking or the data that you are, for example, in real time, if you are sharing some data with other person and you are building your relationship better, then we can frame this whole process in one statement. Okay, my friend is good. Okay, how do you say? Then you explain the whole story. Whole story we don't want because that we are calling as population. We will just ask, give me a sample. How you tell your friend is good? No, I on that day I I told this one, and he has proved that from 30 kilometers he came here and he helped him in that case. Okay, there's one sample. Tell me more. Another sample will give. Another sample will give. They give 10 samples. Then you understand. Okay, understand now. Hypothesis. What I had doubt that you are lying here. Now I have proof. That is not lying. All right. How we humans evolve with respect to relationships, and how we deal with the data that we have and we communicate with humans. Same way, same thing is replicated in terms of them. And we cannot we use the same word as I am using as general person. We cannot use that in mathematics. So we have some technical words that we need to remember to understand the same concept as we are dealing. All right. Okay. Now I hope all of you have understood how inferential statistics work. It is your life itself. That means an AI is an artificial intelligence. But we humans are naturally intelligent. Alright? We know how to build a relationship. We know what to tell, what to not tell, what to imagine, what to not imagine, what to correct ourselves. Everything we understand. So our intelligence itself is being copied here. So now whatever scenario I told, it is trying to copy. So that is the copy. You are natural. You are real. Alright? Okay. I hope all of you understood. Any questions you have? No? You understood now more? Okay. So that is inferential statistics. Inference statistics can be done with the help of various steps. Obtain and start with a theory. Theory is just a story. Okay, just very easy. In terms of, I'm giving an example. Theory is a story actually. Agree? Story until you prove that story is right. Okay, it's theory. Theorem we say. Theorem have you heard of it? Pythagorean theorem. Theorem is theory. Unless until you prove all sides are equal. Okay, generate a research hypothesis based on the theory. So you have a theory as a base. On that you are trying to build something. Got it? We have generate a research hypothesis, then operationalize, execute or use variables, execute this research hypothesis and create the variables. I hope you understand how and why they are research hypothesis means how the hypothesis is being made. Is it a situation or is it an event or is it a person or an object? I'm assuming. So if I'm assuming a person, I will have a variables of different type. If I'm assuming an event, there will be different variables will come. If I'm assuming any of that situation, then I'm assuming something. Okay. I have some variables being created. As we're creating the class, when I say car, you started writing on some variables. When I say truck, you started writing some variables. When I say person or student, you started writing some variables. So there are related variables with the specific assumptions that you're making about an event or an object. So that you're trying to do it here. Says generate a research hypothesis. Based on that, you use the variables or operationalize the research. Operationalize is actually try to implement. Identify or find out population or a data set to which we can apply this study material or this hypothesis or these variables to have been filled with the values. I need those values. So you create the values or generate the or identify or find out the population on which we can experiment on. Alright? That is what happens in chemical labs. What do? They say, I have read this thing and I believe this will happen. That is theory. They are telling a story. Alright. So when they tell the story, they have to, even in colleges, when you tell your idea that I want to do this one, I want to do that one, if the person is intelligent enough in engineering colleges, they say, okay, I understand, the idea is very good. So we'll implement it from tomorrow. We'll start. So the only condition is you bring me the research papers, related research papers. Have you done the research or survey? What survey? Hey, not that. It's a last point. How come you know? Talking about this beginning, idea engineering. Survey we do, right? Initially. What kind of survey we do? Literature survey. Literature survey you have to do. Once you tell the story, immediate next step is tell me the proof. Where is the proof? Who wrote it? Where you read it? Are you a scientist? This is the first time in the world you are predicting? No, somebody has read it, doing the work. How much they have done and what you are explaining. So that is your survey you do. And that is what we are telling here. Hypothesis. You are researching a hypothesis. Alright, you tell a theory, you tell an idea, and they ask you the second step, and you bring them second as well as third. Okay? No, sir, no, madam. In our college, these places you can use that. That they are variables. That means your college is an object, and the places where the problem exists, which you are solving, will become your variables. And you identify the population. Population is many in the engineering colleges, and you apply them. Alright, wherever you are solving the problem, and there will be different parameters that you will be considering. Like, for example, you have any problem you have in college? No? Good college. Okay, many students have a problem in getting marks of assignments. That I cannot discuss on that because I also use assignments. Okay, so we identify the data on which we have to apply the theory as well as concept, everything. We have to practically apply on that. So I need those samples in lab, medical lab, mouse or guinea pigs. The scientists or chemists, they apply the medicines on them, or chimpanzees or whatever human-related medicines are there. They experiment on them and then they see whether it is working or not. Because it is again an assumption. If it is an assumption, we cannot give it to the directly humans. Alright, because it is assumption. That is hypothesis. It will work or not, we don't know. Huh? Those who have taken it, God bless you. Okay. Identify or find a population to which we can apply study material. Generate or form null hypothesis. I hope you understand. Generate or form a null hypothesis for those populations. Okay. The hypothesis that may not lead on to the outcome, but you form them. Collect and gather sample of children from population. Sample of children from population and simply run the study on the samples, not on the whole collection, whole sample, whole population. You apply only on the samples and you generate the outcomes of it. Then perform all the tests of statistical analysis, and then to clarify if obtain the characteristics after experiments of samples are under null hypothesis, so that we can be able to find and reject the null hypothesis which are not supporting our outcomes. All right, if they are different from the expected value, so what is the value that we are getting, and what is the hypothesis that we have done? Can we reject it or we cannot reject it? Are they right or wrong? So both of these we can analyze in the class. Right? This is your steps to understand and to obtain the inferential statistics. Got it? This is how a theoretical concept, if you want to prove as an idea, you have to do all these steps. Then you will have the proof of concept you told in the first step. Got it? Types of inferential statistics. one sample test or of a difference or one sample hypothesis test, confidence interval test, contingency table and chi-square statistics, t-test or ANOVA, we also call Pearson correlation, bivariate and multivariate. All of them one by one. So these are the type of inferential statistics. Alright, they have been formed based on the different methodology that we implemented to arrive at a outcome. That this is my actual outcome that I am expecting. Data, introduction to data. I think this is from the first slide. We have taken it here. I hope all of you understand data set and also understand what is data. It's just one of the theoretical concepts that we have. Data is an essential part of any enterprise business, you understand. And we say it is critical to collect, process, and analyze data flow. And any data that is being collected in businesses has to be analyzed with the help of algorithms so that the data could be useful to the companies. That's why data plays very crucial role in any organization. Data science industry is rapidly expanding. Data science industry, what do they do and why it is expanding? Two questions. Data science industry, when it says data science, it is finding out some information which is readily not visible. All right, you research on the data. Okay, then you will predict that something is there in the data. So you not accurately know. So try to research on the data and try to find out what is the actual outcomes that I can get it, which is useful to my company or to any other organizations. Then we can say that data science is the domain where we try to research on data and try to get some insights which will give us more edge on the data that we are collecting. If I am collecting a student's data that I need to apply data science on them, I will start getting so many insights that it will give me more futuristic view of how the future will look like. Because this data is revealing some points which is going to improve my next process. For example, this time results of 10th standard students is not good. When I say this is one of my inferential statement, I am giving you the complete ultimatum statement, last statement I am making. But when I ask you, so why you are saying like that? So you start giving me the data science view of the data that I collected. Alright? The research you start giving me. I have collected this data and I have found this pattern in that. That's why I am concluding like this. Okay? That's how you can say data science industry, which is dealing with the predicting or identifying some unknown insights from the data. All right. So how it is growing rapidly and why it is growing rapidly? It is growing rapidly. Earlier, companies used to collect the data, but for them it is not at all useful because they are just collecting the data and storing it as a backup. They are not all using it. So now onwards, whatever data they have collected earlier and are still collecting, so all those data will be passed through a pipeline called data analysis dashboards. So those dashboards will consume the data and give you the analysis on the dashboard in terms of the graph, in terms of the numbers. All those things will be taken up. And to create those dashboards, you need to have the algorithms being implemented in the background. All right. So that's why data scientists or data analysts will be hired more and more, and this industry is obviously growing because companies are earning more by revealing more insights in their data. Okay. Simply you understand in terms of if a hotel guy or any of the manufacturing industries
are manufacturing goods based on the sales from the factory. How much I'm producing, I'm selling that much. But whether the sales are happening or not, how will you know? So I get all the data. I'll create a report of it. And I'll see how much I have to produce and how much I should not produce for 1 year. On what month, how much should I produce and how much sales is happening. And if the sales will happen in the future, whether they increase or decrease the sales, that I can understand. With the help of previous data, that's history, I'm trying to predict my future. With the help of the dashboard that I'm giving. Because I can see the graph is giving me some indications. Alright? So that's what data science industry, and it is expanding. Data volume can be a large and making information handling difficult and time consuming. That's why data handling has to be done in a very intelligently as well as in a very efficient manner. Efficient manner with less cost. It has to be done. And there is a technology to handle the data in an efficient manner. That is called a big data technology. Heard of it? Big data. Okay. Can anyone tell me anything about it? Big data. What do you know about that?
Big data is a concept where you handle thousands of GBs or thousands of terabytes. So that much kind of data will be handled. That is big
So
data.
large data sets will be.
Large data.
Anything? Where you heard big data? College. For syllabus it is optional. You are taking it? Anyone else? Okay. Big data is a technology which is going to help help for these servers which are hosting the data to mine the data, data insights. Okay. It is one of the part of data mining technology, where it is going to query, specific information from a very large data sets. Querying is nothing but asking some data from a database. How do you understand this? So querying on a multi-terabyte data will be very time consuming. You just look at your results and just enter your register number and just ask your SQL data to come down your system. It takes so much time and it has to process something. And when all the students of VTO and all the students of the college reach out to one server, it gets easy. Just to search a few data. If I ask you to look for the data, look for one statement, one data I want, but the data set is so large, then it is very difficult for normal systems to go and look for the data. It is like you have a complete farm and you are just looking at one needle in the complete farm. Obviously, it is same like that, and you obviously will be not be able to efficiently do it. It consumes a lot of computing power as well. So what big data will do is it will create its own file system, okay, and that file system will index all the data in such a way that it will allow you to access as well as query information that you are looking for easily and efficiently. All right, and such kind of queries we call them as big queries. All right, so those kind of technologies will help big companies use data science dashboards along with the big data technology to mine the data from the already stored data in companies. I hope all of you understand what is data mining. Mining you understand, right? Data mining is nothing but we just wanted to mine some insights from the data. Alright, some data I wanted, and I'm mining it because there is a huge data which is cluttered one. That is not structured one, that is cluttered one. I want to mine something. That's why I use the data mining. And for the mining, there will be big data helping. And overall, we are using AI. AI is internally using all those technologies here underlying because there are small difficulties. Those technologies will help us to
I understand that. If I ask you to develop an AI system or artificial intelligence or machine learning system to identify how many defective products we have developed till today since 1 year, how many defective products we have developed since 10 years, I mean since 10 years, how many we have developed, and who are the people in the company as a managers, and what are their qualifications. So when we look for this kind of a data, then you need to handle large amount of products being produced and the defects in them and what are the defects in them. So this kind of a data, if you collecting and also analyzing, then you need the help of big data as well as you need the BigQuery, you need a data mining, then you need once you have this some data like population and samples, then you have algorithms needed. Agree? Data presentation. How do you use the data being presented? How do you present the data? We present the data in textual format. We present the data in terms of audible format. We present the data in video format. We present the data in terms of images. We present the data in terms of graphs. We present the data in terms of charts. We present the data in terms of 3D models. We present the data in terms of multidimensional data. Now, in modern technologies, we are going to present data in multidimensional virtual environmental data. Okay, the data presented in the virtual environment. All right, and data can also be presented on a physical surfaces with the help of augmented reality. Okay, so there are different formats in which we can display the data, and there are different forms in which we can display the data, and there are different means of displaying the data. So here we are looking at different forms, different ways in which you can display the data. Now the question here is, why there are so many options we have to display the data that we are collecting or insights? Can anybody have any answer to this? Why do we have so many options to display? We have learned in schools to draw a graph, XY axis. We used to have a graph paper, and we used to draw some points, and we used to, with a scale, we used to join those points. That's what we understand when we say graph. Why do you think, other than that graph, we need more graphs? Okay, one insight. Any other thing?
Obviously, it depends on the situations and the scenarios where which kind of data you are plotting. It depends on that.
Data. That means if the data is different, I will choose a different graphs or representation. Yes, that's
To make
one.
it easily understandable.
You reduce space.
Reduce space of representation data. Yes, that's another parameter. Yes, so to easily understand, I am to easily represent the data, and also based on the data format, whether it is having one parameter, two parameter, or multiple parameters that we can put it onto the graphs, and also to make it more useful in terms of representation. Okay, histogram, we have column chart, we have box plot, pie chart, and scatter plot. Most of them you have already seen. We'll have a look at them. We'll just have a look at these statements. Data visualization is a presentation of data in a graphical format. It helps people to understand significance of data or importance of the data on the graph by summarizing and presenting. Summarizing, we are not presenting everything, we are summarizing on important points, and we are going to present a huge amount of data in a simple and easy to understand format with the help of different elements in a graph, with the different packages. And we also say that in presentation, it will help us to communicate what we wanted to say clearly. Okay. As we do presentations, we do not clutter the slide with all the information. We just put the information which is important for the person to understand. All right. So that way, we represent the information on data on the graph, which are only needed to be represented in terms of graphical elements. Histogram, have you seen histograms like this? Histogram, heard of this? You might not have seen, you might not have used this one, but you might have definitely seen this in most of the cases.
In cricket, runs is scored per over. First over 10 runs is scored, the second over 12 runs, the third over 4 runs.
There is column charts.
That is the histograms.
This way, I think you might have seen comparative charts. Okay. This will be a little different actually. Let's look at it. The histograms represents the frequency of occurrence. Frequency of occurrence of specific phenomena which lie within the specific within the specific range of values and arranged in a consecutive and fixed interval. You understand one by one. Frequency. Understand this word? What does that mean? Frequency. Physics. Other. Okay, pendulum.
Yes.
Number of occurrences. Pattern. It's a pattern. Okay, it's just trying to look at the patterns in terms of how the numbers are very related. All right. Or if you're right, histogram represents the frequency of occurrences. So whatever numbers you are giving, or you are giving the phenomena or any numbers, but they will be having a definite range. All right. That's what we are saying. They lie within the range of specific values and arranged in a consecutive means one by one, obviously, next to each other, and they have the fixed intervals. Fixed intervals. Intervals, I hope you understand. Intervals. Right. Okay.
Time duration.
Time duration. Difference between delay, interval. It's a difference, right? Step by step. Step by step. The interval. It's a span. Okay. So actually, you can understand with whatever you are doing. It's a span. Break. Break. You can say elapse the time. You can say. Okay. You can see we have age and we have from here 0 to 30, 30 to 35, 35 to 40, and 42 the last number. And here we are showing 2 points, 0 to 5, 5 to 1. How many people are there? Okay. And here again we are showing what is the range of that number and how many times that number is repeated. This number is repeated this 1, 2, 3, 4 times. So 4 times this boxes will be filled. So that's how this sales will also happen in this way. 0 to 3, and this is 1 to 120, 122, 130. We have the sales. The number of sales happened. Number of sales. 150. 135 sales happened 3 times. 3 times it is repeating. 2, 2, 2, 2, 2. So that time I can say 2 itself, one number itself 3 times repeated. So I will increase that frequency number. Got it? Okay. We can have a small code example and we try to display this one, and we try to understand how these histograms will give us the insight about the data that we are having in terms of only the range of numbers. Okay, so we have age, income, and sales. So these points plotted in the output shows frequency of each unique value for each attribute.
Import, we have pandas as one of the package. As PD, we are going to rename it, or this is an alias name for the pandas, the whole spelling. Okay, you can make it a short form. Import matplotlib. Okay, this will be one of the package which will be going to intensively used to generate the graphs. Graphs or plots. Matplotlib, in that there is a pie plot, and that package we wanted to use as a PID. Alright, as PID. Create 2D array of table given below. So we have the data, employee data, having the different weights. The two-dimensional matrix. That's it. Alright, having the employee name, employee ID, gender, we have age, and I think number of sales, the weight, and we have, I think this is salary, something.
Pounds. 350 pounds.
It's a weight?
Yes.
Okay, 350 pounds is a weight. Okay. Here we have, I think it's income. Okay, come back to the break. All right. So we have these names here: employee ID, E001, gender we have age, we have 1, 2, 3 is the sales, then we have BMI. I hope you understand BMI. Body mass index. Understand? Okay. Now what is that?
Natural body weight.
How is it? Anybody understand? Right. Please explain. How is it?
So natural body. How is the natural body compared?
Means ideally you are saying athletic like that. Okay.
Is regarding this
Okay. Biologically, we measure how the person is healthy. Okay. What we measure in BMI? Whatever you see.
mass
Okay. Weight you want. Okay, then
for this much age.
This much age?
This much age or this much weight.
weight it has to be there. So that's normal weight. Okay. We also use height. Yes. So we need three parameters: body weight, age, and height. Okay. So that's BMI, body mass index. Then we have last one is an income. Okay, so here we have taken the data set of data, which is around 10 number of employees are having, 10 number of employee data we have. Data frame created with the above data. You understand data frame? Data frame is a table, two-dimensional table, which is holding a data. Okay, that we can call it as a data frame. Right? Frame is one structure that there is a data element. Here we have df equal to, that is data frame equal to PD, that is our pandas dot data frame, and then we have data that is being supplied, asking for you to create a frame. Here we have EMPID, gender, all of them, and that we are giving it as a list of names, column names. And here we are going to create a histogram. We can also create a different graphs on them, but we are using histogram. So hist is one of the short form for the function. It's a function name. And then at last we have to do this statement PL.show. Without this statement, the graph will not be able to. All right. So here we have taken the data. Here we have created a data frame with the help of PD, that is pandas, and we are calling this df.list. And we are going to show this PL.show.
So we can assign y equal to df dot list, and then we can print y. Will that print the chart?
I didn't get you, please.
So df.list, that is a function call, sir, right? So that we can assign to y,
We can assign to y.
and then we can print y.
We can show y. Because we have a imagination that the outcome will look like a black screen something like that. This is a bit late. Let's do this. TMT? Yes, PLD is plot. There are a lot of programs we have. For the columns also we have same thing. We just have used A, sales, everything. Plot dot bar we have it. For charts also. Okay, let's use this one. All of you do this. Okay, we want the data being displayed. So firstly, two libraries we wanted. Import them. The name is pandas and matplotlib. Firstly, we have pandas being imported. And if you do not have that, you will have an yellow line. When you get an yellow line, please let me know. Ready? Okay. No? Then I will install pandas. I mean, for previous example, I think. Used to pandas earlier? We are not used it yet. Look at this command in py.org. In this you can see there is a pandas 2.0.1. This is the command we need to follow to install package called pandas. Okay. Try in your VS Code terminal. In terminal. In terminal, you can install pip install pandas and check if you are already installed with the pip command. If not, I'll tell you the again solution. Pip install pandas, and if it starts installing, well and good. If it says pip is not installed, then let me know. Sorry, it's not bring the package. Pip install pandas. Save it. What is it? It's just term is not installed. That's what I'm saying. If pip is not installed, I will pip is not installed. Matplotlib is not installed. Install that. Same. Pip here. 0, 0, 1.
Requirement already exists.
Sorry. Go back to it. Sorry. Fine. Version. So this is a new version. Fifth version is not installed. Fifth is old one. Yeah. Copy this. Copy this. Right. So fifth editing upgrade. Again, you will upgrade. Not equal, not equal. What is that? If the shape is not installed, it is not installed. Still what is wrong? Where is the yellow?
Requirement already exists.
Okay, so the not installed pip command, pip which is already comes built in when you install Python. When you install Python, you'll actually get the pip in that. You can see on my screen, all of you can see there's a pip command which is already installed in your computer if you have checked this thing. Okay, if you want it, you can again install it again and give it next and ask it to install. Can I reinstall that and see if it is installed? I have another method also. If those who don't want to install or do this method, we have another method also. There is a file we need to download. The file we need to download. I give the reference. You can download that. Please follow these instructions.
Yes, sir. Can we check by going into C drive screen into Python folders?
No, you cannot check it, I think. Yes, there will be pip folder being created. Pip folder is being created. These are the steps you need to follow to install on Windows. Pip must be manually installed on Windows. You might need to use correct version of a file called pypa.io. If you are using an earlier version of the Python pip or pip, get the file and save it in some folder on desktop, and then you need to do that. Can you visit to this website? Type this website name, this name, complete till here. Bootstrap.pypa, bootstrap.pypa.io / then we have get-pip.py.
So first we need
Not that one.
Python package authority.
No.
Get it, not be my
Not search. Directly go there. Go to the desktop. Okay, go to the. I have entered. This URL you entered in your browser. Download it. File. Save it right on desktop. You got the code right. Like this. Can you display? You take this address, paste it in the address bar, not in Google address bar. Paste it, you get a code, black white code. Okay, save it as this. You save that on a desktop somewhere. Okay. File and store it in the same directory as Python installed. You can directly store that. Go to the user C drive. Go to C drive is there. Finish it. C drive. C drive users. Users. Your computer name. Inside that app data. Your computer name inside that app data, inside that local app data is there, that local, in that programs, C drive, users, then your computer name, then app data, there, then inside app data you have local, your programs. In programs, we have Python. Have Python? It's written actually. Go to this place just a second. View you go. Here we have hidden checkboxes. Are they unchecked or checked? You check it. Hidden boxes, hidden items is unchecked. Is there? Click on that. Hide items is there. Hidden items. View. You see? Hi, you are at this place. Python and Python 3. Inside that, you can find this thing. DLL.
Which one is 310 or 311?
311. Presently, you are using 311. Inside that, you have these things, and copy that desktop file and bring it. Paste it here.
That file is
Yes, copy and paste it. Bring the desktop file, minimize this. Get that file from. Copy that file.
desktop.
Get that.
File or this
Copy that. File, copy.
This one, sir?
Yes, file, copy. No, that is folder.
This one, sir?
Only file. Only file. The file name is get-pip. Only that file you want it. See where it is. Copy that. Tanushree, what happened?
In C drive, sir. Second April, it is showing part of the April it is showing part of C drive. C
Now, the item management CPU is there. In that view, there is a option called hidden items. Is there? This check on check this check. Maximize it. Done. This problem.
Just pixel yes.
No, that is fine. Try solving the command.
How to use minus of
There is a command called pip place. Save. Change the values range is there. So your range is from 30 smallest value to largest value. That's the range. Right? That's it. Did you finish? No, okay. Is it Keonicsx? Click command. Okay, shall I show? Just a second. In app data, local programs.
so the term pip is not recognized.
Okay, we'll follow the next procedure now immediately. Go back to the where the file is stored. Get hyphen pip. There is already where the file is stored on desktop. Get hyphen pip.
Get
Where is it stored? It's here only.
desktop.
On desktop in your folder.
Yeah, in the folder of
Open that folder. Right click in the open space. Open space.
right click and open space.
In open space of the window. Blank space. Git bash. Python space.
Python
Space. Get hyphen pip dot UI.
Slash.
Not slash. It is hyphen pip dot UI. Enter.
dollar sign is
Huh? No, what is the answer? Slash.
Python was not common, but can be used on the
Yes.
This space here, we can have this. Space, right? Minus.